1.5 Modeling and solving problems with polynomial functions. So our main strategy for doing this is going to be able to make an equation and type it into Desmos to find our answer, but sometimes we'll also do it algebraically too. So I will show you both of those ways. So a piece of cardboard is 30 centimeters long and 25 centimeters wide, and it is used to make a box with no lid. Each squares of side length x centimeters are cut from the corners and sides and folded up. So we got a piece of cardboard that's 25 by 30. We're cutting sides off here so that when we fold it, it will look like this. So we have a box with no lid. So this side length right here is x. All of them are x there. Which means when we fold it up, this side is x. So we want to find the volume of the box. So we actually need that bottom because that's going to give us the dimensions of the bottom of the box. So volume is found by doing length times width times height. So our length is going to be 25 subtract 2x. Our width is going to be 30 subtract 2x, and our height is going to be x. So our volume is x times 25 minus 2x times 30 minus 2x. So we can tell a lot about this. So first of all, we can tell that the degree is 3. We can find the leading coefficient by multiplying all of our numbers. So 1 times negative 2 times negative 2, which is 4, which means it's positive, so it's going from quadrant 3 to quadrant 1. We can also tell the constant, so because we have an x out in front, there is no constant, it's 0. So this question's asking us to write a polynomial function, to graph it, and find the domain. So we'll do that on the next page. And then we also want to find the maximum volume of the box and what size the square should be cut out. So I want you to pause the video and I want you to type this into Desmos and graph it. So your graph should look like this. So first of all, let's do the domain portion. So I cannot have it go negative. If it goes negative, then we have negative volume, which is not acceptable. So we're only going to be going from here to here, and we can't go further than this because this 15 is bigger than, it would be a cutout size bigger than our box because our box has a length of 25. So our domain is going to be x such that 0 is less than x and less than 12.5 for all the real numbers. So that is our first section. And really, 12.5 is not going to work, and neither is 0. So it actually should probably just be less than. That doesn't matter. That's good enough. If you could figure that out, I'm happy with that. The maximum volume is going to be right here. So our y values are representing the volume, and our x value is how much we should cut out. So the max volume that we can have for this cardboard box is 1,512.04 centimeters cubed, and the size of x to be cut out is going to be 4.527 centimeters. So that is that solution to that word problem. Okay, example 2. I also think it's important to tell you that I've just been talking with the pause button on the video, and I did this whole example already on pause. So this is the second time of me saying it and the first time of you hearing it. Alright, Clara and 3 friends were born on March 11th. Leslie is 5 years younger than Clara. Let's just start with Clara is x. So we'll do this as we read. So Leslie is 5 years younger than Clara, so x minus 5 is Leslie. Mike is 2 years older than Clara, so x plus 2 is Mike. Thomas is 3 years older than Clara, so x plus 3 equals Thomas. On March 11th, 2011, the product of their ages was 61,136, greater than the sum of their ages. So on one side we have the product, So x, x minus 5, x plus 2, x plus 3, all timesing. And on the other side, we have the addition. And because we know that the product is more than the addition, oops, we need to add the 61,136 to the addition side. So this is our equation. To plug it into Desmos, we actually need everything to be on one side. So we're going to go, well, first of all, let's simplify. So on this side, we have 1, 2, 3, 4 x's. And then we're going to simplify all of the numbers. And you should get 6, 1, 132. So we keep the left side the same. And we're going to just move everything to the other side. So we're going to minus 4x and we're going to minus 61, 132. So our equation that we're going to type into Desmos is right here. Minus 4x minus 61, 132. So pause the video and go ahead and type this into Desmos. So it should look like this. And your answers are going to be the x-intercepts. So this one is extraneous. If you didn't remember that word, I know someone did. Okay, so it doesn't work because it is negative and we're not having negative ages. So that means that Clara is 17 years old. So we go back to our equations. So Clara is 17, which means that Leslie is 12. And Mike is 19, and Thomas is 20. So that is all of their ages. Thank you, Desmos. Okay, last example. This one we can do algebraically. And whenever it's one you can do algebraically, I'll tell you that so that you know to do that. To the first question, so we've got a box. And the dimensions are 13 by 15. We're cutting off sides. And we don't know what x is, but we want the volume to equal 143 this time. So our length is going to be 13 minus 2x, and our width is going to be 15 minus 2x. And our height is going to be x. So volume is equal to x times 13 minus 2x times 15 minus 2x. And we're going to make it 143 is equal to the, I'm not going to write that again. I'm just going to write this. Okay, so we want to solve for x. So what we have to do is we have to get everything to one side. So we're going to have to distribute in. So we have, I want to change colors. We have 13x minus 2x squared times 15 minus 2x. And now we're going to just FOIL this out. So multiply out here and multiply here. So I want you to pause the video and I want to see if you can fully distribute this properly. So what you should get is 195x minus 30x squared minus 26x squared plus 4x cubed is 143, and then we would minus 143 from both sides. And now we can simplify it, and I'm going to put it in descending order, so we should get 0 is equal to 4x cubed minus 56x squared plus 195x minus 143. So from here we're going to see if we can factor. So let's try plugging in 1, negative 1, and so on. So let's try 1. I'm going to not do the negatives because we're dealing with volume and real life things, and the negatives aren't going to work anyways, so what a waste of time. But if you plug in a 1, it works. So we're going to synthetic divide. 1, 4, negative 56, 195, negative 143. Bring down the 4. 4 times 1 is 4. Add those together to get negative 52. 52 times 1, or negative 52 times 1 is negative 52. Add those together to get 143. 143 times 1 is 0. So we have x minus 1 times 4x squared minus 52x plus 143. So I'm just going to take this, I'm going to move it to the next page because I want more room. Okay, so I already know I have one solution. One solution is that the cardboard box has a cutout of x equals 1, which means that the side lengths of our cardboard box would be 13 minus 2 times 1, which is 11, and 15 times minus 2 times 1, which is 13. So the dimensions would be 13 by 11 by 1. We got to check to make sure there's not another answer. I don't really feel like factoring that. That looks trash. So I'm going to use my favorite formula in the world, the quadratic formula. So x equals, remember you can always use the quadratic formula to find your x-intercepts. So negative b plus or minus the square root of a b squared minus 4ac all over 2a. Okay, so we have negative 52 plus or minus the square root of negative 52 squared minus 4 times 143 all over 2 times 4. So we have 52 plus or minus the square root. Simplify under that radical, and if you simplify under the radical you should get 416. So we have 52 plus or minus the square root of 416 over 8. So this gives us two possible answers. So we could do 52 plus root 416 over 8. If we type that in, we should get 3.95. Or we could do 52 subtract the square root of 416 over 8, and I would get 9.04. This isn't going to work, because if I try to take away 2 times 9 on either of these, it's not going to work. So this one is extraneous. The first one should work. So our dimensions could also be 13 minus 2 times 3.95 and 15 minus 2 times 3.95, which gets us the numbers 7.1 and 5.1. Yeah, this one's 5.1 and this one's 7.1. So this is one solution, and the other solution is 3.95 by 5.1 by 7.1. So there are two solutions here. And that is the end of our first unit. Thank you for spending this time with me. I'll see you next time. Bye!